you want to go cheap, you replace the carbon, but you can also replace the motor. Okay, so let's see. Let's talk about door locks. These also another accessories in the automotive systems.
Today I'm going to show you how the power door lock systems work in your car. Now the power door lock system can be operated using three methods. The first of which is the traditional key-style method. The second of which is the keyless entry method. And the third of which is the toggle switch on the front door. Now the guts of the power door lock system is buried within the latch mechanism itself, so we're going to need to remove the door panel to have a closer look. So here we are with the door panel removed. We have a lock striker over here that's held on by 3 bolts. We've also got these 2 cables over here that go to the lock and door handle respectively.
The inside door lock and handle.
Here we have the child safety lockout that prevents this handle from operating this door latch. Now the door strike actually has 2 positions, the first of which just catches the door, and the second of which actually locks it against the body of the car.
That is a smart design for safety. See, if you don't have a double locking point like that, you always have to slam the door strongly in order for it to latch, but for safety purposes, you want it to be easily latched, but you know that's not the full latch. You get it? So the first latch is very easy, right? I mean, even if a wind blows on your car door and it clicks, that's already engaged, and so that's for safety purposes. So if you don't slam it hard enough, it still latches, right? You know, you won't get thrown out. But for proper lock, then you slam the door. So this double locking point, double stage locking is for safety purposes.
I can then use the handle to release it off. Now in order to disassemble this lock, there's 2 10mm bolts, one on either side, that hold on this door handle. And I'm going to pull out this door handle over here, and you can see it's just a lever mechanism that pulls up, which actually pushes this little rod down into the mechanism over there. I'm just going to come in here and disconnect this. I'm going to remove these Torx bolts here. Inside of the door cavity, on the door handle here, we have the lock actuator and latch assembly. So here I have the handle, lock, and latch assembly removed from the vehicle. As I pull this handle here, you can clearly see that this rod is actually going to push down. And it's actually going to push down on this little tab over here, which is what's going to unlock the latch from the door. Now this lock actuator only has 2 wires running to it. Other vehicles will actually have a built-in lock detection switch to tell if it's in the locked or unlocked state for the alarm system, but this vehicle probably uses the door switch. So if you take a little tour of this guy, you can see we've got the latch mechanism over there, and then we've got these 2 lines here that run out to the interior door handle. So we've got a little plastic cover that covers everything here. I'm just going to rip it off. So here we have a good look at the latch mechanism from the inside. The top cable here leads to the interior door handle. You see when I pull that, a bunch of levers move. And the bottom cable here leads to the door lock mechanism inside.
So the challenge here is a pretty intricate mechanism. The challenge here is how all these handles work together, right? Because you don't want a weird situation where you pull the inside door handle and on the outside it goes out, right? And it just looks funny and it's not elegant. And then you have the child lock, and then you have the door lock, and then you have the motor rotating, unlocking and locking, and so you have all these things happening at the same time. It's a pretty intricate mechanism.
Just disconnect these cables here so we can get them out of the way. So when I pull on the interior door handle, what happens is this little C-shaped member here pivots about this point over here. We've got another little member underneath here that comes off of it. And
so this is the inside door handle. That's what you pull when you pull the door handle. It moves the same mechanism as your outside door handle, but your door handle will not pop out when you pull on it.
Translates up and down. And that's actually connected to this exterior door handle connection over here, which pivots about this point over here. All of that comes together to activate this little notch over here to turn this cam, and this cam then deactivates the latch over here to open the door. Now what happens when you lock the door is this cam here actually moves the slider mechanism away, so this tooth can no longer engage with this cam on the latch.
Okay, do you guys see that? So if you pull this away, it cannot move that.
Instead, it just skips right past it. Therefore, you cannot use the exterior or the interior door handle to unlatch that door.
So you can still pull it, but you cannot unlock or rotate the cam.
Now the interior door handle has a little bit of play before it actually engages, and when it does engage, it also engages the exterior door handle tab over here. However, the exterior door handle doesn't actually open when you open the interior door handle. That's because it's got this little hole over here that actually allows this rod to translate up and down, so that way the connections are not linked. However, when the exterior door handle is engaged, it'll just push down on that tab, which will then unlock the door. But we've got this little slider inside of here that prevents the exterior door handle's movement from being transferred over to the interior door handle. Now the child lock off, you can see we have the interior door handle that will engage this tab over here on the inside, and that's what's going to open the door. However, if I slide this guy over, it's actually going to move the entire slider mechanism over, causing this tab to skip past that tab, and therefore your interior door handle has been disabled.
So the child lock disables the interior door handle, but the outside door handle still works because it only moves that piece that is connected to the interior door handle.
However, the exterior door handle can still unlock the door. Now while the interior door lock unit connects over here, this little cam that pivots about this main pivot point here actually has a third connection over here, and that goes to this little lever that's electronically powered by a motor inside of the lock actuator. Therefore, the lock actuator can power up and power door locks electronically by moving the mechanism back and forth. And here's a better look at that one from the other side. Now the lock actuator is just held on by two Phillips screws that I'm going to remove next. And I can just remove that lock actuator. You can see this is the little lever arm that moves back and forth electronically. I have no idea why it says R on it, and this side says L. Maybe you can actually flip it around, but this actually came from a left-handed door. Alright, now it's time to wreck this open. Now inside of the actuator, you can see we have a standard 12-volt DC motor. It has a spiral gear. It turns this helical gear over here. When the helical gear spins up, this little notch over here is actually going to move this tab on the smaller gear over for a further gear reduction, and that's actually going to move this quarter gear over here, which is in turn going to move this arm to either lock or unlock the door. Now the reason why it's not just a straight gear ratio is to allow for extra free play so that the door lock can be locked and unlocked manually.
So they make the mechanism such that you can rotate it with your finger, right? But the motor can also flip over it. But when you move it with your hand, you're not moving the motor, right? There is some free play.
Inside. And looking closely, you can see there's actually a little arm inside of there that sticks up and slides inside of here to make a little cam slider mechanism. So it's actually activating something down below. I'm going to remove the screw that holds this actuator on, and I can pop off this arm here, and that'll allow me to pop this quarter gear up and pull it out. And you can see that arm that I was talking about earlier that moves back and forth. And then remove this little small gear here. The things are actually getting pretty greasy inside of here, so I'm just going to come with my brother's old trousers and wipe up all that grease. And now if I lift off this gear over here, you can see we've got like a little spiral on the inside here. On the bottom of this gear we have this other tab here that actually engages with a spring to move it back and forth to give it self-centering spring pressure. And I'll just use my brother's toothbrush to pick up that spring. Boy, did they really put a lot of grease in this. Just gonna have to wipe this up again. Now further underneath that spring I have the spring retainer. What the? There's actually electrical contacts underneath. So much grease on here, I don't even know how these contacts will actually conduct. This is basically the moment where I have...
Actually, grease and electrical contact does not interfere. In fact, in many electrical contact, if you want to make it waterproof, you put dielectric grease. It's a grease that does not interfere with electricity. Right? So you can put dielectric grease. They often put that on connectors that can get water splashed on. So if you have sensors that keeps getting error, you put some of the dielectric grease on it, you'll fix it.
No idea what's going on inside of here and why Nissan chose to do this kind of design.
Let me just explain it in a shorter version. What this does is when it swings to the lock position, it will de-energize the motor once it reaches the locking position. So, in other words, when you reach your target, turn off the motor. When you reach the other target, also turn off the motor. So I think it's a brilliant idea rather than using some microcontroller to detect the current and the torque. You know, in the power window situation, there is a current limiter, so if you get your fingers pinched, it turns off the motor. But you don't need such fancy electronics here. It's governed mechanically. So when you reach the other side, the contact detach, and so your motor turns off. And I think that's good enough to talk about the power door locks. We'll close with talking about the battery and alternator systems. Now some of these videos get a little bit too deep on the chemistry. We will skip that. So it's a lead acid battery. Let me just give you the gist of it. A battery is a chemical storage, right? It's a chemical energy storage. So you have the anode, the cathode. In the lead acid battery, we're not talking about lithium batteries yet. We'll talk about that in the second half of the course. Lead acid batteries, PB and PbO2. So you basically have, I forgot which one is which. Lead and lead oxide, and you have the hydrogen sulfuric acid in between, and that's your the electrolyte within the battery. Okay, what happens when you discharge the battery? Both becomes you got sulfuric ions here and also here, and this becomes H2O, which is water. And so when you charge the battery, you get it back to this state. So it's a reversible, rechargeable battery systems. That's the big view, big picture. Okay. So you have this alternator, which is the charger, and then you got the battery, and the big consumption is of course the starter. That's the big consumer of the current.
So will draw an extremely large current, possibly hundreds of amps, but this is only for a few seconds. This large current demand is going to reduce the energy storage of the battery, so we will need to top this back up. Connected to the engine is an alternator. The alternator is rotated by the engine, and as it rotates, it generates electricity. This electricity is fed back into the battery to recharge it. While the engine is running, the alternator recharges the battery, but it also provides the electrical power for things such as lighting and the music system.
Your battery nowadays powers up a lot more than the starter motors. Your ignition is actually the spark from on your spark plug is taken mainly from the battery. So when your battery dies, the alternator is not capable of running the engine these days because it's an electronic ignition systems.
When the demand for electricity in the car exceeds what the alternator can provide, then the battery will provide this additional power, which again drains the battery. If the engine is switched off, the alternator stops rotating and recharging the battery. So the battery will provide the full electrical power to the car until it's dead. At this point, the battery can't provide enough generators around.
Of course, if your engine is off and you turn on the lights, then it runs out. So it's composed of 6 cells. Each cell is about 2.1 volts, and so you got 6 cells. It's about 12.6 volts, right? And this is a lead acid, and so this is 6 in series. All these 6 cells is in series.
2.1 volts of DC or direct current. Each cell is connected in series. The negative of one cell is connected to the positive of the next cell to give us a total voltage of around 12.6 volts. It's the same as if you connected household alkaline batteries together. The voltages prefers water.
Okay,
We
so
have
this
the
is what I
positive
explained.
electrode, which is the cathode. It reacts with the sulfate.
So you got PB and PbO2 PbO2 is the plus, Pb is the anode, and you got the sulfuric acid here.
In the electrolyte. This will form a layer of lead sulfate on the cathode terminal. During this reaction, an oxygen ion is ejected from the cathode and into the electrolyte. Once in the electrolyte, these oxygen ions will combine with the hydrogen ions to form water. At the same time, the lead atoms on the anode are going to react with the sulfate ions in the electrolyte. This reaction will create a layer of lead sulfate around the electrode. During this reaction, 2 electrons are released and collected in the negative terminal. So now we have a build-up of electrons on the negative terminal.
You know, electron flow is basically electricity.
As electrons are negatively charged, this means we have a difference in charge across the 2 terminals, and we can measure this with a voltmeter or a multimeter, and start to reverse the reaction. The electrons enter.
Okay, so this is what an empty battery looks like. You got water, you got lead sulfide in the majority of the electrodes. This is, you still need some amount of polarity in order to recharge this thing.
To the negative terminal and rejoin with the lead sulfate, releasing the sulfate into the electrolyte to leave just lead on the negative plate. The sulfate ions enter the electrolyte and combine with the hydrogen ions to release the oxygen ions, and so the electrolyte acid becomes stronger. The oxygen ions combine with the lead to create lead oxide, and this releases the sulfate back into the electrolyte, making it even more stronger.
So this is the charging chemistry.
If we were to leave the battery to fully discharge for too long or too many times, it becomes very difficult to reverse the chemical reaction.
Which brings us to the concept of deep cycling. Lead acid batteries does not like deep cycling. Deep cycling is when you discharge the battery up to close to zero. And when it's close to zero, it's very hard to charge it, and this deep cycling actually damages the battery chemistry. There are batteries, car batteries, that is able to sustain a lot of deep cycling, but this is bad. Okay, so when you turn on the lights and your battery comes empty, you jump start it. Yeah, you can do that sometimes. Don't do that too often. You'll damage your battery age very quick. Nowadays, you don't have to fill up the electrolytes. I mean, most of it are gels now.
Additionally, the sulfate layer could break away from the electrodes and accumulate at the bottom of the battery. This means it will no longer participate in the chemical reaction, so the battery needs to be repaired or replaced.
Okay, so that's when the battery dies. Any questions so far, by the way? If you have questions, you know, you can just... I don't know which one to use on these. This one is a bit...
The alternator. This device is an essential part of every combustion engine vehicle's electrical system. So what does it do and how does it work? That's what we'll be covering in this video, which is sponsored by Engineering Mindset. We find the alternator within the engine bay of the car. The shaft of the alternator is connected to the engine via a belt and pulley. When the engine...
hold on, let me use the other video first. It has a good mechanical overview. The alternator. Okay,
Alternators are the work the conduction. To generate electricity in a coil, either the coil should rotate with respect to magnetic field, or a magnetic field should rotate with respect to the coil.
It's basically a generator, right?
In the case of alternator, the latter approach is used. Rotor and armature coils are the two main parts of an alternator. Rotor produces a rotating magnetic flux. Armature coils are stationary. And rotating magnetic flux associated with the rotor induces electricity in the armature coils. This kind of rotor shown here is known as salient pole rotor. For gaining better insight of its working, let's consider a rotor with just 4 poles. This will...
Okay, so basically you have 4 poles, coil. You energize it, you rotate it, so you have a rotating magnetic flux, which creates current on the stator.
Generate an alternating EMF across the winding. Here is a slowed down version of rotor-stator interaction. For this 4-pole system,
okay, I'll just explain it. So you because of this distance from the armature, when it's totally aligned, then you generate maximum voltage. But if you are off by a little bit, then your voltage decreases. So you have this, basically the sinusoidal wave, which is why we have AC electricity now, right? So it generates a sinusoidal wave. But you can add more armature coils, and so to put this in a more optimal way, you generate a 3-phase current. So you have 3 of these sinusoidal wave generated. Okay? So you have the 3 sine wave overlapping, and that's called a 3-phase power. Now we are charging a battery, so what do we need to do? From this 3-phase to charge the battery. Right? Yeah, we need to make it a DC, right? Using a rectifier, which is basically diodes. But your alternator actually generates AC. You cannot generate DC voltage, by the way. You always generate AC. You use a rectifier to make it a DC. So you also put in some mechanical, additional mechanical elements, the plates, and additional poles. Okay? So it is designed to operate at a low RPM, but you can adjust the amount of electricity it generates based on the magnetic field strength of this rotor. And these insulated lamina, if you notice any transformer and all that, you always have the laminated plates. Is to prevent any eddy current across it. So these plates are laminated, so you cannot transmit current from this side to this side, because you can generate eddy currents in these things. And that is generally true for transformers, basically. Okay? And you put this on to assemble everything. The slip ring basically allows you to conduct electricity and generates magnetic field on the rotor itself. So an alternator needs electricity to generate electricity. In a way, you can think of it that way. And sometimes you can energize this using your battery or an extra DC generator. In my understanding, it's usually you use the battery to actually generate the electricity, but maybe there are different types. Okay, so this extra generator is to generate electricity, to generate the magnetic flux, and then generates a bigger electricity. So that's why an alternator cannot work on its own, just rotating it. It doesn't work that way. Okay, so you actually modulate or actually adjust the magnetic field here according to the demand or the voltage, charging voltage of the battery itself. Okay? So that sums up, I guess that sums up our topic today. I think that's good enough for alternator discussion. Any questions? Any topics you'd like to talk about further on accessories?
I want to ask about
Yeah.
when your car doesn't start and then you push it and it will start. What happens?
You basically use the momentum of the car to rotate the engine.
Oh,
Right.
the crank.
Yes, to rotate the crank. So basically you're doing the opposite of an engine. The engine rotates your wheel, and this time you use your wheel to rotate the engine. That's basically what you do. I didn't include a video on how the starter works. Actually, that's a good one. It uses a solenoid. Let me just get the picture. So if you look at the starter, you have the DC motor. This is the big DC motor. It can have a rush current of like 30, 50 amps at an instant. Okay, it consumes a lot of current. That's why the wires are that big. But on top of that is a solenoid contact. So because this thing consumes that huge of a current, if you ask your, well, we're talking about old school now, rotating your keys, and then if you make the contact there for 50 amps, it's going to generate a lot of sparks. Okay, so you want to contain this contacting and transmitting 50 amps of current, not near your hand. Okay, safety. So what it does, this thing, let's see if it has a good animation on it. Okay, so this thing actually slides up. It's a magnetic relay. Okay, it's a magnetic relay. So what you rotate actually activates a magnet, and the magnet makes the contact for the 50 amps of big current. So when your starter dies, oftentimes it's actually your solenoid contact that dies. Motors do not fail that often, by the way, which is, I think, it's intriguing. Okay, so this thing actually is just a magnetic solenoid magnet.
Flywheel before the motor starts to spin. As the pinion slides towards the flywheel,
It also have a pinion that actually deactivate this thing once it overspins.
it slightly rotates on its axis, as shown here. This rotation is achieved by using a helical spline. This rotation helps meshing the pinion with the flywheel more conveniently. As the pinion and flywheel is properly meshed, the contactor switch gets closed, and the motor spins. As we can observe that the pinion is considerably small compared to the flywheel, the gear ratio of the flywheel and pinion is generally from 50 to 1 to 20 to 1.
So what you don't want to happen is when you're done starting the engine, you don't want the engine to rotate this guy, right? So we need a way to detach the starter motor once the engine is on.
High torque obtained from this gear reduction is still insufficient to crank the engine. So, a planetary gear set is introduced to increase the torque.
That's just a ratio.
Planetary gears are incredibly useful for large gear reductions with less weight and limited space. It consists of a sun gear, a ring gear, a carrier, and a set of planet gears. In starters, the ring gear is fixed, the sun gear is the input, and the planet carrier is the
We'll
output.
talk about this tomorrow, by the
For
way.
the setup shown here, the gear ratio is 7 to 1. The combined gear reduction results in enough torque to spin the engine, to prevent backdrive of the motor, which
back
will attach
drivable
to
again.
the
The
excessive
same
speed.
concept,
This
right?
is done by releasing the ignition switch, which de-energizes the solenoid, and the pinion returns back.
So when you start, the pinion shows out, right? It goes out and it engages the thing, the flywheel. So the other thing that the solenoid does is actually, see that? Okay? And so it retracts the gear when it's not active. It's only extended when it's active. And that's why when you keep cranking it while the engine is on, you hear the sound, right? So you need to turn it off and it'll retract. So that's the starter. Any other questions? Starter solenoids is wear items after, I don't know, 15 years, 10, 15 years old. And then your magnetic coil starts to wear out. Alright, well, can go ahead and do the post test. How are you doing with the homeworks? Catching up?
Yeah.
Okay. And to be honest with you, I still don't know what kind of exams do I want to do, because this is the first time we teach this course. I teach this course at least. You have any ideas? What should we do for an exam? Just a theoretical multiple choice thing? Or try to think of an alternative? Huh?
Case study.
Case study? Okay. Interesting.
Like a mix, like multiple choice, like we get mark and then case study we like balance it out.
Okay. Okay. We can do a case study. Like based on the theoretical understanding, then how would you kind of troubleshoot certain situations? We can do that. It's a bit more interesting than just doing the post. Go ahead and do the post test before I forgot. If you're done.